This lesson is on limiting reagents. This goes along with Roman numeral 2 in the Unit 10 Honors Notes packet. Remember when we started talking about stoichiometry, we said that you needed to know the amount of reactants and the amount of products to be able to most efficiently make what you wanted to make. Look at this picture here. I'm making water. So I've got 8 hydrogens and 3 oxygens. As you know, water is in a 2-to-1 ratio of hydrogen to oxygen. So I used up all 3 of these oxygens, and each of them is bonded to 2 hydrogens, as you can see. But I didn't need those last 2 hydrogens. This is a case where I have a limiting reagent. A limiting reagent limits how much of what I can make. In this case, which one limited how many waters I could make? The oxygen did, because I ran out of it. Hydrogen here is what we call an excess reagent. So in your notes packet, the general concept, chemical reactions are like well-followed recipes. Just like a good recipe, you need a certain amount of each type of beginning substance, the reactants, to produce an adequate amount of your ending substances, the products. Sometimes the amount of product that you can produce is limited because you run out of one of the reactants. The one that you run out of is the limiting reagent, and the one that there is still some left of is the excess reagent. We can even see this in everyday applications. For example, you're making sandwiches for a party. For every 1 bun, you're going to use 3 slices of ham. Use the following steps to figure out which one you will run out of first if you have 45 buns and 122 slices of ham. The first thing we're going to do is choose one of our givens to determine how much of the other I would need. We're going to use dimensional analysis. In this case, I'll go ahead and start with the 45 buns and figure out how much ham I would need. Now, I see a conversion factor here. I'll need 1 bun for every 3 pieces of ham. Of course, I could flip that over too, depending on which way I needed it. And I've got a couple of notes here, 45 buns and 122 slices of ham. Okay, so I said I'm going to choose to start with buns, so 45 buns. Is my conversion factor like it needs to be? You should have recognized buns needs to go on the bottom. So I'm actually going to put 3 ham on top, 1 bun on the bottom. Since the 3 is on top, I will multiply by the 3 to get 135 pieces of ham. So what that means is if I indeed have 45 buns, it would take 135 pieces of ham to make the sandwiches like I decided I was going to, 3 slices per bun. Well, step 2, we want to determine if the amount I need from step 1 is more or less than the amount I actually have. Well, we said we needed 135 pieces of ham to use up all 45 buns. How many pieces of ham do I actually have? According to the problem, I have 122 pieces of ham or slices of ham. So, since 122 is less than 135, I don't really have enough ham to use all 45 buns if I'm going to stick to my recipe. So I'm going to draw some conclusions here about limiting and excess reagents. Since there are less pieces of ham than required, ham must be the limiting reagent because I'm going to run out of it. Therefore, buns are the excess reagent. Think of excess as extra. I have more than I need. Sodium chloride can be prepared by the reaction of sodium metal with chlorine gas. Find the limiting and excess reagents for each situation. We're going to follow the same steps that we did with the ham and sandwich situation. We're just going to use our chemicals instead. Okay, so I'll start with 6.7 moles of sodium. Remember, you just want to choose one of your givens. We've actually got 2 here. I usually just start with the first one. It doesn't really matter though. I want to do stoichiometry. I'm going from mole to mole. Therefore, I only need 1 step, just the middle of that stoichiometry map. And hopefully you remember where the conversion factor numbers come from when it's mole to mole. It comes from the coefficients from the balanced equation, which I have right here. So I'm going to put 2 moles of sodium down here because that's 2. And then because there's no coefficient here on the top, I've got 1 mole of chlorine. I will solve 6.70 divided by 2, since the 2 is on the bottom, and that gives me 3.35 moles of chlorine. Now, is that how much I would want to have or how much I actually have? Is how much I want to have. How much do I actually have? Because I need to determine if the amount you need in step 1 is more or less than the amount you actually have. Well, this is how much I would want or need. Up here, given to me, was the amount that I have. So 3.35 is more than 3.20. Okay, so again, my need is what I calculated, and what I have was given to me in the problem. So now I can draw conclusions as to what my limiting reagent and my excess are. Well, I need more than I have of chlorine. So chlorine is the one I'm going to run out of. Therefore, chlorine is the limiting reagent. If chlorine is limiting, then sodium would be what we would call the excess reagent. So chlorine is limiting, sodium is excess. Okay, since you've already done a lot of stoichiometry, all we're really doing today is adding on that evaluation of what the limiting and excess reagent is. Go ahead and pause the video here and try B and C, then you should be able to check your answers. So in B, you should have seen that you needed 6.4 moles of chlorine, but you only have 7.4. Therefore, chlorine is an excess reagent and sodium is limiting. I didn't mean you only have 7.4, I meant you have 7.4, which is more than 6.4, so you have more than you need of chlorine. In C, you would need 138 grams of chlorine, and you actually have more than that, 175 grams given in the problem. So again, chlorine is excess and sodium is limiting. If you don't understand these, try to look back through it, make sure that you're getting the right numbers. The calculations were 6.4 and 138, and you can ask questions in class tomorrow if you still can't get it. I also want you to try 2A and B. I suggest again that you pause, do it for yourself, and then check the answers. In A, you would need 32 liters of oxygen. Since there is less than 43, since this is less than 43, hydrogen is your limiting reagent and oxygen is the excess reagent. And then finally in 2B, you would need 2.2 times 10 to the 34th molecules of oxygen. Since this is more than 5.6 times 10 to the 16th, oxygen is the limiting reagent and hydrogen is the excess reagent. In evaluating this, notice I didn't compare the 2.2 to the 5.6. It's that times 10 to the power, because that's what's going to make this one a lot bigger than this one down here. 10 to the 34th means that you would move that decimal over 34 times, whereas 10 to the 16th you would only move the decimal 16 times. So come to class tomorrow prepared to ask questions if you have any.